Hello children, today we are going to discuss a new topic in our set theory. In our earlier classes, we come to know how many types of sets are there, how to write in roster form and how to write in set builder form, how to find the subsets, what are the equal sets and what are the equivalent sets, power set. Like that, many topics we discussed in our previous classes. Today, we have an interesting concept of the Venn diagrams. Venn diagrams. When we narrate a story without any pictures, while listening the story, we can understand the story and we can keep those characters in our mind for 1 day or 2 days or maximum for 1 week. If the same story, if we explain with audio visuals, like characters you are able to see, the action, the face expression, everything when you are going to see, by observing the characters like audio visuals, you can remember in long time. For examples, when we saw a movie, maximum we never forget about that story, we never forget about the characters in that movie. Why? What is the reason? What is the reason in the sense? Then we are able to observe the characters on the screen, the body movement, the facial expressions, everything we are able to observe on the screen, so that those characters will be there in our mind long time. That is the difference between the oral and audio visual. Why sir? Why you are discussing this audio visual concept? Means set theory is a concept. While we explain the concepts, a few students can understand at a time, few more students can understand after explaining 2 to 3 times, few more students or they may not able to understand the concept, because they may have a confusion how to express in roster form and how to express in set builder form, and which one is roster and which one is set builder form. Like that, there is a confusion. To avoid all those confusions, John Venn an English logician has introduced the Venn diagram concepts for set theory. So what is the meaning of Venn diagrams? Venn, the name Venn came from the mathematician John Venn, and diagrams. So what he has done, John Venn, he introduced the diagrams to represent the sets. So far we know sets can be represented in 2 ways. One is set builder form, another one is roster form. The third one was given by the John Venn. What is that? Representing the sets in diagrams, means in the form of pictures. So when we are able to represent the sets in the form of diagrams, it is very easy to understand for us. So as a student, we can remember the information for a long time, and it is very easy to represent the sets in the form of diagrams. So So to understand that concept, John Venn has introduced the diagrams. Okay, it is very good. Now how to represent, sir? How to represent? What are the pictures we are going to use? In mathematics, what are the pictures we have to represent? Yes. In mathematics, we have a few shapes. What are the shapes we have? We have some polygons. Polygons are nothing but what? A simple closed figures. A simple closed figures. What are the polygons? We have types of polygons are what? Triangle, what? Quadrilaterals, pentagon, hexagon, septagon, octagon, nonagon, decagon, like that. We have plenty polygons. Here we are going to use triangles and quadrilaterals. Mainly three shapes we are going to represent. What are they? The first one, we can use circle or we can use oval shape, and some cases we use square boxes, and some cases we use rectangular boxes. So these are the four symbols or four diagrams we are going to use to represent the sets. So what are the symbols? The first shape we are going to use circle. The second one we are going to use what is this? Oval shape. And the next one we are going to use square. And next we are going to use rectangle. So these are the four symbols or four shapes we are going to use to represent the sets. Now let us see how to represent, what to represent, and all now we are going to learn in this class. So sets can be represented in the form of diagrams using the different shapes. Now we have different types of sets and we have different types of shapes. How to represent the shapes for which kind of sets? Majorly sets are two types. One is subset, another one is superset. Our school is superset, our classroom is subset. For all subset, we use the symbol circle or oval shapes. For superset, we use always rectangular shape. When we come for our school is nothing but what? Superset. Superset means which is nothing but called universal set. Universal set, which is denoted by capital U. So for all universal sets, we use the shape square. We use the shape square or rectangle, usually rectangle we use. And for all remaining subsets, as we know that universal set is one bigger one. More than that there is no another set. Then we consider remaining sets. All are nothing but parts of a universal set. So that universal set always we represent in the shape of rectangle, and the subsets means the parts are always we represent either in the form of circle or in the shape of oval. So let us see how to represent and how to locate the number. For example, when we have real numbers. So far, as per our knowledge, real numbers is the biggest set we have. Real numbers is the biggest number system, means that is the universal set. So, the real numbers I am representing with universal set. This is nothing but universal set and real numbers. In what are the different types of numbers we have? Yes, we have natural numbers. Next we have whole numbers. Next we have integers. Next we have rational numbers, and we have irrational numbers. So natural numbers is a part of a real numbers. That's why we are using circle. Whole numbers is also part of a real numbers. Integers is part of a real numbers. Rational number is part of a real numbers. Surds are also part of a real numbers. This is about our number system. This is about our number system. Like this, very easily we can represent the sets in the form of diagrams. Now let us see a few examples so that you can have more clarity how to represent the sets in the form of Venn diagrams. Here we have one diagram for us, one information was given. Using this one information also we can identify the sets. Here we have universal set, and in this we have one subset, let it be A. Here I have 1, 5, 9, 3, 7, 2, 4, 6, 8 and 10. Now this is the information was given for us. Now I am asking, what is the universal set and what is the set A? When this is the question given for you, you can easily identify universal set. Universal set means what I said, the entire rectangular box. So this is the rectangular shape we have. This entire rectangular shape represents universal set. What are the elements we have in universal set? Universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now what is the set A? Set A means the circle. This shape represents the set A. Now within the circle, what are the elements we have? 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. So easily we are able to identify the elements which are there in the sets. So that is the advantage of Venn diagram. No one can come and explain to you. No need to explain anyone. Seeing the Venn diagram itself, you can understand what are the elements we have in the universal set and what are the elements we have in the set A also. Very easily you can identify. Now let us see one more problem here based on the Venn diagram study. So now this is the Venn diagram has given for us. Now I am asking that how many shapes are there? Here I am able to identify 3 shapes. One is rectangular shape and 2 circle shapes. How many shapes are there? Those many sets we have. So rectangular represent one set, circle represent another set, this circle represent another set. We have total 3 sets. Now what are the sets we have? As I told you, the rectangular shape represents always universal set. So that's why it was mentioned as U. U indicates universal set. Now what are the elements we have in universal set? The universal set. All the elements which are there in the rectangular box. What are they? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now set A and set B. Set A, the bigger one, this is the circle. This is the circle, represent set A. Now in this big circle, what are the elements we have? 2, 4, 6, 8, 10. You may ask that, sir, 4 and 6 are there in another circle. Of course, if it is there in the other circle, but this circle is a part of A. This is a part of A. So that these elements are also comes under set A. These elements are also comes under set A. So that, now what are the elements we have in set A? 2, 4, 6, 8 and 10. Now set B. Here we have set B, means this small circle. This is the small circle represents for us set B. Now in this small circle, what are the elements we have? 4 and 6. So 4 comma 6. From this Venn diagram, what we can understand? B is a part of A is part of universal set. Means that I can say from this, B is a subset of A, B is subset of universal set, A is also subset of universal set. Means B is a part of set A, B is a part of universal set, A is also part of universal set. As we know that every set is nothing but subset of universal set. So A is subset for a universal set, B is also subset for a universal set, and B is a part of A. So from this Venn diagram, easily we can understand B is subset of A is subset of universal set, B is also subset of universal set. So this is the advantage of Venn diagram. Means easily we can identify the sets, easily we can identify the relation between the sets also. Now we have operations on sets. Till now we have seen the Venn diagrams, how to represent sets in the form of a diagrams. After that, the next concept is operations. Operations on sets. Now, in number system, we have 4 fundamental operations. What are they? Addition, subtraction, multiplication and division. That is based on the numbers. Now, sets. Our present concept is sets. Now, on sets, what are the operations we have? Which type of operations we have? So, do you have addition, subtraction, multiplication, division on sets? No, not like that. We have a different kind of operations. Total, we have 3 operations major. What are they? The first operation is union of sets. The second operation is intersection of sets, and the third one is difference. Difference of sets. So these are the 3 fundamental operations we have on sets. One is union of sets, intersection of sets and difference of sets. So what is the meaning of union and what is the meaning of intersection and what is the meaning of difference? That I will explain you with one example so that you can have a brief idea about the operations. In our next class, we see elaborate concepts of operations on sets. Now, what is the meaning of union? What is the meaning of intersection? And what is the meaning of difference? Anyway, difference is nothing but like subtraction. But there we know how to subtract the numbers, but here how to subtract the sets is different. Now, first, union of sets. Union of sets is nothing but a simple word. In one word, I will tell you. Combining of the elements, which are presenting in both the sets. So operation means definitely we need minimum 2 sets to do addition or subtraction or multiplication or division. Definitely we require 2 numbers. Similarly, when we need to perform the operations on sets, there also minimum how many sets are required? Minimum 2 sets are required. So, what is the meaning of union? Unions. So, in general, our society also, we used to have unions. Labor union. So, RTC drivers union, auto union, teachers union. Like that, we come to know many union. What is the meaning of unions? Suppose auto union, meaning, so all auto members together forms a group. That is nothing but called auto union. RTC drivers union. All RTC drivers together form a group. That is nothing but called union. Here also we have 2 sets, set A, set B. So set A we have some element, set B we have some element. All these 2 elements together forms another set. Set A we have a few elements, set B we have few more elements. So both the elements are together forms another group, means another set. That is nothing but called union of sets. So a simple definition for sets is combining of the elements which are presenting in both the sets. That is nothing but operations on union. Now let us come for intersection. Intersection means collecting the common elements which are presenting in both the sets. So, collecting the common elements which are presenting in both the sets. So, intersection means set A we have few elements, set B also we have few elements. In both the elements, we need to collect the common elements. So, collecting of the common elements from both the sets is nothing but called intersection. First one is what? Combining all. Second one is collecting only the common elements and forming a set. That is nothing but called intersection on sets. That is another operation. Now, difference of these sets. Difference means what? Subtracting. How to subtract the elements? Subtracting in the elements in the sense. So, from both the sets, we need to eliminate the common elements. So, whatever the elements are left over after eliminating from the first set, that is nothing but called difference of the set. Difference in the sense we are not subtracting the elements. We are eliminating the common elements. We are eliminating the common elements from both the sets. Eliminating common element from both the sets. After eliminating, whatever the elements are left over in the first set, that is nothing but called difference of the sets. So you may be having some confusion between difference of sets. By seeing a few examples, we can get very clear idea. So union of sets, intersection of sets, difference of sets. Union of sets, combining all the elements. Intersection of sets, collecting the common elements. Difference of the set, just subtracting the common elements. So for every operation, like in addition, subtraction, multiplication, we have symbols. Whenever we see the symbol, immediately you can notice it is addition. This is subtraction. This is multiplication. And this is division. Like that. So by seeing the symbol itself, you can understand what is the operation we are going to perform between the numbers. Similarly, for these three operations also, we have particular symbols. What are they? Union. This is the symbol for union. Intersection. This is the symbol for intersection. Difference, that I am using minus only for difference. So here small u I am writing. This is nothing but called union. Earlier also we used to know this is for what? This is for universal set. Universal set. Wherever universal set is there, they used to mention the bigger u like this. Now this is the symbol indicates that union operation. This is the symbol indicates for us union operation. Union symbol, if you reverse it, you will have the intersection operation, and this is the difference operation. Now let us see one example I will tell you so that you can have more clarity regarding the operations on sets. In next class we see still more problems. For example, to understand, let A is equal to 1, 2, 3, 4, 5, 6. B is equal to 4, 5, 6, 7, 8. These are the two sets I have, set A and set B. Now between these two sets, I am going to perform the union, intersection and difference operations. Let us see the first one, A union B. What I am doing, as I told you, this is the symbol for union. A union B. What is the meaning? What is the meaning of union? Collecting all the elements from both the sets. Let us see here. Now the first set, 1, 2, 3, 4, 5, 6 union, and the second set 4, 5, 6, 7, 8. Now what I am telling, we need to combine. Here how many elements are there? 6. Here how many elements are there? 5. Total how many elements are there? 11. 11 we are going to combine. So while combining, you have to observe that in set, repetitions are not allowed. Repetitions are not allowed. So first I am going to write the elements of first set. 1, 2, 3, 4, 5, 6. All these are what? From the first set. Now coming to the second set. Second set, what are the elements are there? 4. Already 4 is there. 5 is there. 6 is there. Next 7 and 8. Now total how many elements we have? 8 elements. Hope you understood. Set A we have 6 elements. Set B we have 5 elements. All the elements we are combining. While mixing the elements, you need to avoid the repetition. We need to avoid the repetition of the elements. Only one time you have to consider. So finally, A union B. How many elements I have? 8 elements. Now coming to the second one. A intersection B. So intersection, first set 1, 2, 3, 4, 5, 6, and intersection 4, 5, 6, 7, 8. As I told you, intersection. What is the meaning of intersection? What is the meaning of intersection? Is collecting the common elements. Now let us see what are the common elements we have. 4, 5, 6, 4, 5, 6. So the common elements are 4, 5. So intersection of sets is nothing but collecting the common elements. Next we go for the third operation, difference of sets. A minus B. What are the elements in A? 1, 2, 3, 4, 5, 6. What are the elements in B? 4, 5, 6, 7, 8. So while subtracting the elements, it is not the meaning of 1 minus 4 minus 3, 2 minus 5 minus 3. That is not the meaning of subtraction. Here the subtraction is entirely different. First we need to eliminate the common elements. 4, 5, 6, 4, 5, 6. Common elements are eliminated successfully. Now after eliminating the common elements, you need to select only the elements left in the first set. In first set, what are the elements are left over? 1, 2, 3. You have to choose only those elements. This is nothing but difference operation. This is nothing but A minus B. Now similarly, we can go for B minus A. So 4, 5, 6, 7, 8 minus 1, 2, 3, 4, 5, 6. So 4, 5, 6, 4, 5, 6 common. Now 7, 8. The elements which are left over in the first set are 7, 8. This is about B minus A. So here the difference is quite different. And now you may ask a question. Sir, you have done A union B. Why can't B union A? A intersection B. Why can't B intersection B? Here, calculating A union B or B union A, both are gives the same result. Like addition. 2 plus 3, 5. 3 plus 2, 5. A intersection B, B intersection A. It also gives the same result. Like multiplication. 2 3s are 6, 3 2s are 6. So, this is about a brief information on sets operations. In our next class, we go for elaborate discussion about the sets of operations, and we have Venn diagrams for union, intersection, difference of the sets also. Hari Om. Thank you.